So this is our word problems section, and each of the problems I'm going to be able to create two equations and two unknowns and solve them using mostly the elimination method, possibly the substitution method. But essentially, for any word problem, I want to read the problem first to know what's going to be solved for. After I read the problem and know what's going to be solved for, I'm going to create names for what I'm trying to find. And after I have my names, the verbiage of the problem is going to help me get to equations. And then I'll stack the equations on top of each other and solve them either by the elimination or the substitution method. And I'm going to check and write my answer. Try to keep this video manageable in terms of time because my videos are getting too long and I don't want to do that to you. So, in problem 2, I'm just going to read through it. It talks about the sum of two numbers. That means I'm adding two numbers, a smaller number and a bigger number, I imagine. It says the difference of 3 times the smaller number and twice the larger number is -10. Find the numbers. Ugh. So, let me come up with equations. I need an equation for the first sentence, sum of two numbers, which means I need to have names for the numbers. I'm going to just let x be the smaller number. And I'm going to let y be the larger number. Adding is so nice. So the first sentence, the sum of the two numbers, means if I just add the two numbers, I get 80 because the is in the first sentence is 80. The first sentence, the sum of two numbers, that's just adding x and y. Now, this is a mess. The difference is a minus word, so I know I'm going to get a subtraction. The difference of 3 times the smaller number and twice the larger number is -10. So this means 3 times the smaller number, which is 3 times x, minus twice the larger number, which is 2 times y. That difference is -10. So the difference gives me the subtraction, and what I'm subtracting, keeping the order of what's written, 3 times the smaller, which is 3x, and twice the larger, which is 2y, and then is equals -10. So there's my system of equations that I need to solve. I'm going to get an answer for x and an answer for y, and I'm going to eliminate the y's by making the top equation have a positive 2y, which will cancel with the -2y that's already sitting in the bottom equation. From that marathon video, this is the skill that we learned in that section 3.4. So I'm going to multiply through the top equation and get -2x minus 2y equals -160. I could be saying negatives, but it doesn't matter. I'm going to mess up if I do that. I should not multiply by a negative, I should multiply by a positive. Otherwise, I'm getting double negatives. That's not good. So let me multiply the top by +2 to get it a positive 2y and make the top positive 2x plus 2y equals to 160. I started figuring out what I was going to do on the next step, and I was like, ugh, things aren't going to cancel if I do that, because I need opposites, same number, opposite signs, in order to get the canceling that I need. Now I'm going to add the 2x and 3x and get 5x, cancel the 2y's, and on the right hand side the numbers have opposite signs, so I'm going to subtract and pick up a 150. And now I'm just going to divide by 5, divide by 5. That's going to give me x equals to 30. That's the smaller number. And now I'm going to solve for y using the equation x plus y equal to 80. So I'm going to plug 30 in for x. I'm going to leave the y to be solved for. Also going to leave the equals 80. And then I'm going to minus 30 and minus 30. That's going to give me y equals to 50. So my answer is going to be the smaller number is 30, and the larger number is 50. I can check, I won't check all of these, but to check, if I plug 30 in for x and 50 in for y into the top equation, if I go to check the top equation, I'd go is 30 for x and 50 for y, will it make the top equation true? And that I can do in my head just fine. And I'll do the same for the bottom. In the bottom equation, if I plug in 30 for x and 80 for y, will that make that a true statement? So 3 times 30 minus 2 times 80. Oh, because the bottom it should be 50. Here I am trying to check, and I'm making more mistakes checking. So 3 times 30 minus 2 times 50, and I get negative 10 equal to negative 10. So checking, it's just a matter of plugging the numbers back into the problem. I'm checking because I have answers here. If I get something that strays from my answers, then I'm going to go ahead and full out check. Let's do number 3 together. Just because it's important, there's a trick. Because difference is subtraction, and subtraction order sometimes is important. It's going to be important here. So in problem 3, I'm going to let x be this time the larger number as opposed to the smaller number, and I'll show you why in a second. It really doesn't matter, but I'm looking for 2 numbers in problem 3, and I need to subtract them because the first sentence says the difference of 2 numbers is 20, and it's always the case if you do a big number minus a small number, you get a positive, but if you do a small number minus a big number, you get a negative. So when I do this first sentence, I need to do big number minus the small number when I set up my equation. If I flip-flopped it, there's no way I'm going to get 20, I'm going to get a negative. So I need to define which one was big, and I knew I needed to write the big number first. I like writing x's first, that's why I made x be the bigger number. So I read through this problem. I'm not sure I gave you the time to do that. So first sentence, the difference of 2 numbers, I just subtract the x and the y, or the y and the x. I'll get 20 depending on which one's bigger in my definition. And then second sentence, 2 times the larger plus the smaller is 70. Find the numbers. So let me make the first equation. I need to subtract the numbers and get 20 because the is 20 is the equals 20. And difference means subtract. It didn't say how to subtract, but logically I know that big number minus small number is going to give me positive. So I set it up that way. On the second sentence, 2 times the larger. 2 times the larger is 2 times x. Plus is a plus sign that keeps the order. Plus the smaller number, which is y, is, which is equal, is 70. That's the equation I'm going to need to solve in problem 3. I'm going to sneak 1s in front of the variables that don't have coefficients. I don't know if it's going to make it easier for you, but I like to have them there sometimes. These are set up to already eliminate the y. I don't need to do any multiplying. I can go straight into adding. I'm going to go 1x plus 2x and get 3x. The y's have opposites, so they'll cancel. 20 plus 70 is 90. And now I'm going to divide by 3. Divide by 3. It's going to give me x equal to 30. So the larger number is 30, and let me solve for y. I can use any equation to solve for y. I don't like messing with negatives, so I'm going to use the bottom equation to solve for y because it's not going to force me to work with a negative. So I'm going to go 2 times 30 plus y equals to 70. It's going to give me 60 plus y equal to 70, and then minus 60 minus 60 will give me y equal to 10. So the smaller number is 10. I'm kind of punting on writing sentences. You can write sentences, but as long as you have words next to the answer, that's kind of more common. And I can kind of just quickly tell that this feels good because if I subtract the numbers, bigger number minus smaller number, I get 20. So I'm not physically checking it, but I'm kind of eyeballing it, and it seems like it's going to be okay. Next problem are some money problems. We had a couple of money problems back to back. 5 and 6 are actually solved similarly, so I'm going to solve 6 and let you solve 5. When I read through problem 6, it talks about 200 people being on a flight, and maybe 200 paying customers on a flight. Some of the people paid $400 to travel in first class. That seems cheap. The other paid $250 to fly in coach. The total money paid by the passengers is $56,000. How many passengers were in coach and how many flew first class? It seems more difficult than it's going to turn out to be. I'm trying to find out how many coach passengers there were and how many first class. I might do my letters C for the number of coach passengers and F for the number of first class passengers, just so when I get an answer I can tell which answer I have real quickly. And for these money problems, I need to create 2 equations. And one's going to be for the total number of people on the flight. I need to equate an equation for that there's going to be 200 passengers. That's going to be one of my equations. My goal is to create an equation to represent there's 200 passengers on the flight. And the other equation is going to represent what the passengers paid combined, $56,000. And it's not that hard actually to get the equation. The equation for the number of passengers is just the number of coach passengers plus the number of first class passengers has to equal all 200 passengers, assuming every passenger is one or the other. So that's a trivial equation. Number of coach passengers plus the number of first class passengers equals 200 passengers. Now I got to figure out how much each person paid, or each group of people paid. Each coach person paid $250, so the amount paid towards the $56,000 for the coach people are $250 times the number of coach passengers, and the amount paid by the first class passengers is the $400 each first class passenger paid times the number of first class passengers. This represents the amount of money paid by the coach passengers, total amount. This represents the total amount of money paid by the first class passengers. The amount of money paid by all the coach passengers combined plus the amount of money paid by all the first class passengers combined comes out to the $56,000. Now I have 2 equations and 2 unknowns. I don't know that this is easier to solve by substitution or elimination. I'm going to go ahead and do substitution because the numbers are so big I don't want to multiply by such a large number. I'm going to solve this problem by elimination, or substitution should I say, and I'm going to solve the top equation for C by minusing F from both sides. I'm going to rewrite the top equation as C equals minus F plus 200. And it might well help me if I emphasize that that's C equals minus 1F plus 200. I'm going to substitute that into the bottom equation. I'm going to write 250 times negative 1F plus C plus 400F, not plus C, what am I writing here? It's negative 1F plus, let me recalibrate. I should write 250 times, and then in for the C, negative 1F plus 200 plus 400F equals 56,000. Now I'm going to clear the parentheses. I'm going to go 250 times minus 1F and get minus 250F. And then I'm going to do 250 times 200. You got to use a calculator for this section. The numbers are getting kind of crazy big. That multiplication of the 250 times 200 gives me 50,000, like $50,000 maybe. And then plus 400F equals 56,000. On the left-hand side, I'm going to combine the minus 250F plus the 400F and get 150F. So I can rewrite the left-hand side as 150 times the number of first, for what, 150F plus 50,000 equals 56,000. I'm going to next subtract 50,000. That's going to give me 150F equals 6,000. And then I want my calculator again. When I divide by 150, divide by 150. On the left-hand side, I get the number of first-class passengers, which is F. On the right-hand side, I get 40. I know the other answer because I know there's 200 people. If there's 40 first class, there's 160 coach. But let me solve for C formally. You can solve in your head if you can't. If you can, I'm going to use the equation C plus F equals 200. I should have used that equation, but oh well. I'm going to go C plus 40 equals 200. And then minus 40 minus 40 gives me C equals 160. So there were 160 coach passengers and 40 first class passengers. Adequate enough for an answer. Let's do 7 together. Maybe pause the video and try to do it. This is a similar money problem. And then we'll pause and do a part 2 because we're going to get into the world of box word problems, which I love because they make them so easy. So, Etta, my niece, has quarters and dimes. She has a total of 20 coins and the value of her coins is $2.60. How many of each coins does she have? I imagine you can fiddle around and figure out the answer to this, but I'm going to do it with algebra. I'm going to let Q equal the number of quarters that Etta has. And D equal the number of dimes that Etta has. I'm going to create 2 equations. One equation that says she has 20 coins, and another equation that represents her having $2.60. Real similar to the airplane problem. Maybe with this as inspiration, you can pause the video and get an answer yourself. If not, I'll work it for you. My first equation, in either order, it's going to say the number of quarters plus the number of dimes equals the 20 coins. I could have it as the number of dimes plus the number of quarters, it doesn't matter, equals 20. And now the value of the quarters are worth 25 cents, so 25 cents times the number of quarters would be the value of my quarters, her quarters, plus 10 cents times the number of dimes has to equal the $2.60. That's the system of equations. I'm going to solve it again by substitution. I'm going to take the top equation, and it doesn't matter what I solve it for, I don't think. Yeah, let me take this top equation and solve it for D. So I'm going to use the top equation, Q plus D equals to 20. I'm going to minus Q from both sides. That's going to give me D equals minus Q plus 20, and I snuck a 1 in front of that Q. Now I'm going to substitute this into the bottom equation and get 0.25 Q plus 0.10 times negative 1 Q plus 20 equals 2.60. Notice I didn't take the time to write a 0 preceding the decimal, which is good habit, but it's not necessary. I'm going to just solve this equation for Q. I'm going to need my calculator because I don't want to do the decimals by hand. To clear the parentheses, I multiply 0.10 times negative 1 and get negative 0.10 Q. When I multiply the 0.10 times the 20, I get 2. On the left-hand side, I'm doing 25 cents minus 10 cents essentially, and I'm getting 15 cents times Q plus 2 equals 260. Now I'm going to subtract 2 from both sides. My calculator is going to put me into fraction mode. I'm going to change it to decimal. When I do this subtraction on the right hand side, I have to hit the SD button to get the decimal that I'm kind of desiring. And now I'm going to divide. And that's going to give me, well, let me do this, 0.6 divided by 0.15. That's going to give me 4 quarters. So part of the answer is Etta has 4 quarters. She has 20 coins total, so the other 16 are dimes. To get that formally, I would say the number of quarters plus the number of dimes equals 20. 4 quarters plus the number of dimes equals 20. And then do the algebra to solve for the number of dimes. And I'll get that she has 4 quarters and 16 dimes. So we'll do a part 2. These problems fit together fairly nicely, and all the problems in part 2 are also they're going to be a different kind of problem, and they're going to fit together pretty well. They're going to be problems that I do box algebra with, and they're going to need major calculator work. The numbers are kind of unpleasant.